In addition to undergoing nucleophilic substitution reactions, alkyl halides can also undergo elimination reaction. In a nucleophilic substitution reaction, the halogen in the alkyl halide is going to get replaced by the nucleophile. So for this particular reaction, the product that is formed is going to look like this, where the Y is a new nucleophile that's been substituted for X. But when an alkyl halide undergoes an elimination reaction, it leads to the formation of an alkene. Here is the product that is obtained for this alkyl halide. Now notice the halogen is removed from one carbon, whereas the hydrogen is removed from the adjacent carbon. And there is a double bond that is formed between the two carbons from which the atoms were removed. So this is a substitution reaction, and this one is an elimination reaction. Just as we have seen in some nucleophilic substitution reactions, there are two different types of elimination reactions. One is E2 elimination reaction and the other one is E1 elimination reaction. Let's now first look into the E2 elimination reaction. Now, what is an E2 elimination reaction? The E right here stands for elimination, and the number 2 right here, it stands for bimolecular. So just as we have seen in the case of SN2 reaction, the E2 reaction is a bimolecular reaction where the rate of the reaction is going to be dependent on the alkyl halide and as well as the base. So which means as you increase the concentration, or if you change the concentration of the alkyl halide or concentration of the base, there is going to be change in the rate of the reaction. Let's now look into the mechanism for E2 elimination reaction. Here is the mechanism for the E2 elimination reaction. It's going to be super simple. First, to begin with, the base is going to go abstract in hydrogen, the beta hydrogen. Now, what is the beta hydrogen? Let's first find out what is the alpha carbon. The alpha carbon is the carbon where the halogen is attached. Okay. And the carbon next to it is called as a beta carbon, and any hydrogens that is attached to it is called as a beta hydrogen. So this is the beta hydrogen. And in here, there are two beta hydrogens. The base first comes and abstracts the beta hydrogen. Okay, this is the alpha carbon, beta carbon, and this is the beta hydrogen. The base comes and abstracts the beta hydrogen, and this is going to put the double bond here. This bond is going to shift in here to form a double bond, and the Br is going to leave. Okay, remember the E2 reaction is going to take place all in one step, where the abstraction of the hydrogen and the formation of the double bond and the removal of the leaving group is all going to take place in the same step. We also need to notice here that the halogen that's getting removed and as well as the hydrogen that is being removed from this alkyl halide needs to be in antiposition with respect to each other. This process of elimination of a proton and an halide ion is called as dehydrohalogenation, or beta elimination, or simply 1,2 elimination. So on the whole, in a dehydrohalogenation, a halogen is going to come off from the alpha carbon, right? And the hydrogen is going to come off from the beta carbon. Okay. Here again, the weakest base is the best leaving group because we want the halogen to leave from the substrate, leave from the alkyl halide. So therefore, the alkyl iodides are more reactive in an E2 elimination reaction compared to alkyl bromides, chlorides, and fluorides.